Till the last video, you guys have studied about continuity, correct? What is continuity and how it works, what is what, everything you have learned. Now, this particular video onwards, we look into the next concept, that is the differentiability and differentiation. All right. Now, let's look into what is differentiability. Okay. Now, again, we go back to the concept of continuity and limits. From there only, we come to the concept of differentiability. All right. Suppose if you have some function f of x, all right. Say you have a function f of x. Now, that function f of x, suppose if you take a value of limit as x tending to some value h, assume. Suppose if I do f of x minus f of h divided by x minus h. Now, generally, we used to write this as f dash of x, right? This is what you used to write. Remember, if you remember last year when you learnt about differentiation, the introduction to calculus, this is what we did, correct? Okay, now when we talk about differentiability, so differentiability talks about whether the condition for the function to be able to differentiate. So what is the condition for the function to be, that can be differentiated? That particular condition is basically differentiability. Understood? Now, whenever we talk about differentiability, we always consider the limit, we consider the function, and then we calculate the derivative of that particular function. This is what we mean by differentiability. Understood? Now, since we have this, we are in the concept of differentiability, what you need to understand is that whenever you have a function, some particular function, it is differentiable only if it is continuous. All right, only it is continuous. Now, there are certain theorems based on this one. Okay, now we look into one theorem and we are going to prove that particular theorem. All right, the theorem goes something like this. See what we have is, so we have theorem 1. Okay, the particular theorem is, if the function, see, if the function is differentiable at C, some point C, then it is also continuous. Then it is also continuous at x is equal to C. So this is basically the theorem what we need to prove. That means if the function is differentiable, that means it is also continuous. Understood? But not the other part need not be always true. But anyway, now let's look into this one. If the function is differentiable at x is equal to C, then it is also continuous at that particular point, right? So first what we'll do, we'll take the derivative part. That is limit as x tending to C, f of x minus f of C divided by x minus C. All right, now here we are going to take, this is basically f dash of C, because I'm substituting a value of C onto the function, so we'll get f dash of C. Okay, now what if x is not equal to C? What if? Then what we'll do, we can take the function into consideration, that f of x minus f of C. Okay, now multiply and divide this entire equation by x minus C. Okay, now x is not equal to C, right? So it's a non-zero value. If it was a zero value, then you cannot multiply and divide. You can't divide by 0, isn't it? So since it's a non-zero value, I can multiply, I can divide, I can do all possibility of all the algebraic operations. All possibilities are there. Fine. So in this case, what we'll do now is we multiply and divide by x minus c. So if you do that, so once you multiply and divide, so multiply and divide or divide and multiply, whatever, by x minus c, so we'll get f of x minus f of c by x minus c into x minus c, correct? Now what we do, we are going to apply limit. All right. Now this is nothing but f of x minus f of c, isn't it? So we'll write that down in the next part. So what do we get now? F of x minus f of c. This is nothing but f of x minus f of c by x minus c times x minus c, correct? Apply limit on both the sides. Limit f of x minus f of c as x tending to c is equal to limit f of x minus f of c divided by x minus c times x minus c, but limit is extending to c. LHS right now you don't touch at all, keep it as it is. That means this is going to become limit as extending to c f of x minus f of c, and here this is going to become limit as extending to c f of x minus f of c by x minus c into limit at x minus c as extending to c. Remember this, the limits, the algebra of limits, addition, multiplication, subtraction, those things. Alright. Next, what do we do? So we are going to take the same thing on the left hand side also. That is, we have limit as extending to c f of x minus limit as extending to c f of c, right, is equal to, guys, look at this one. What does this particular value indicate? This is nothing but f dash of c, isn't it? F dash of c. And what does this value indicate? If you substitute x as c, don't you think you'll get c minus c? C minus c is what? 0. So f dash of c into 0. Now let me repeat this point again. Now what we have is on the left hand side, limit f of x minus limit f of c, correct? On the right hand side, what do we have? The first part, whatever I just encircled, see this part, this is nothing but f dash of c, because that's the definition of derivative, isn't it? Next, if you apply c in the value of x, you will get c minus c, and c minus c is 0. So you can just substitute 0 in this case. Well and good. Now, what do we have? Limit f of x as extends to c minus limit f of c as extends to c is equal to 0. 0 into anything is 0. Here, guys, if you look at this on the second equation, that is in this particular equation, you don't even have a value of x, isn't it? You just have c, which basically is a function. It's a particular value. There is no variable involved at all. There is just a constant value c. So what do we get here? If you take it, you'll get limit as extending to c f of x is equal to, because this goes on the right hand side, is equal to. So limit makes no difference here because my f of c is a constant, like a particular valued function, isn't it? F of c. Now, isn't this the condition for the function to be continuous? So what did we just prove? We just proved that if a function is differentiable, then it is continuous. This is basically the first theorem proof. Clear? Now, in the next one, we'll go into the different types of rules and theorems and corollary and everything. Then we'll look into the problems part after.